Alright, silly people, here's the situation. We're going to be checking the conditions in which this function here, f of x equals x to the nu, is in Hilbert space, particularly the interval of nu where it is in Hilbert space. Um, so for it to be in Hilbert space, the integral over all space of the square modulus of it has to be less than infinity, right? But all space in this context is just 0 to 1. So we're doing the integral of x to the nu square modulus of that from 0 to 1, and seeing the case where it's not infinity. So that just doing the square modulus real quick, it is going to be x to the 2 nu, and then doing the integral of that, you get x to the 2 nu, x to the 2 nu plus 1 over 2 nu plus 1, evaluated from 0 to 1. And then you're going to plug in the endpoints, so 1 is just going to give you a 1 up top, and 0 would give you 0, so that's the result of the integral. That has to be less than infinity for it to be in Hilbert space, which means the denominator can't be 0. So 2 nu plus 1 cannot be equal to 0, which if you do a little bit of algebra on that, you see that nu cannot be equal to minus 1/2. So that tells you the interval for nu. It's that minus infinity less than nu less than minus 1/2, and minus 1/2 less than nu less than infinity is the range in which nu can be for it to be in Hilbert space. Right. For the next bit, all of these next things are for the specific case of nu equals 1/2. So if nu equals 1/2 is f of x in Hilbert space, well, yeah, it's not minus 1/2, so we did a good thing there. Is x f of x in Hilbert space? Well, if it's nu equals 1/2, then that's just x times x to the 1/2, which is x to the 3/2, which is essentially a new value of 3/2, which is not minus 1/2, so this one's good. The next one is dx f of x, if that is in Hilbert space, so it's going to be the derivative of x to the 1/2, which is x to the minus 1/2 over 2, which is essentially a constant times a new value of minus 1/2, which is literally the only value of nu which would diverge. So this one is not in Hilbert space, as it turns out. All right.